Good evening, one and all. We, on behalf of the SREC Alumni Association and the Department of Computer Science Engineering, welcome you all for the 99th webinar talk. VR and AR simulation technologies in oil and gas. We welcome speaker of the day, Mr. Sujith Menon, faculty members, current students, and all alumni friends. Mr. Sujith has completed his MSc Software Engineering in 2004. After his degree at SREC, he has joined as a customer support engineer at CAD Emirates, Dubai, and worked there for a year and a half. Then he worked as a regional IT coordinator at SMB Offshore Dubai for 2.5 years. Since July 2009, for almost 2 years, he worked as a senior IT help desk engineer at Al Wastamani Group, Dubai. Then for the next 2 years, he was with Mukwano Industries Limited, Uganda, as MIS head. Currently, since 2012 October, for the past 9.5 years, he is with Green World Group, Dubai, as an executive director, HR and operations. He is an analytical IT, HR and operations professional in oil and gas with financial expertise, delivering strong technical solutions that solve business problems. He always keeps an eye on bottom line business benefits. Over to you, sir.
Thank you, Mr. Thomas and Vasanth sir. It's been a pleasure. Let me see if I can find start with the video as well. And yes, good evening to all of you. My name is Sujith Menon, as rightly mentioned on your screen, and thank you so much for the brief introduction. And it's always an honor to be a part of the SREC alumni. I've always been listening to the recent podcast over the last year and a half. And very promptly, I should also extend my sincere gratitude to Perumal sir, who was instrumental in reaching out as well to me, and then followed by the alumni team to make this happen today. So just to put it into perspective, as you can see on your screens, I thought I'll choose a topic which is something relevant to my line of current work. Yes, on the LinkedIn profile, it says I work as Executive Director for HR and Operations. Yes, that's one bit of it. So I work as a combination of onshore and offshore. So I thought for the subject today, I'll take an offshore topic, which is a little more technical and could relate to the current world of technology. So simply put, VR is your virtual reality, and then we talk about AR, which is augmented reality. How it has evolved and how it has made its way into oil and gas. I think the current topic as well, when we speak about fluctuating prices, this is one commodity that you would see which definitely sends the stock markets either performing well or it even crashes. So my role currently with the firm that I work is I'm in charge of fleet IT operations as well. When I'm offshore, which means my profile is to, I normally sail on vessels with rigs, basically. These can be floating rigs, which are out there in the sea, and sometimes these can be land rigs as well. And when you talk about offshore and when you talk about the machineries that you are on these platforms, there's a lot that goes into not just the engineering aspect of it. There's a lot that goes into the functional aspect. Now, when we talk about functional, it's how we train people. It's how we try and make sure that the end user is able to sort of work with these technologies. It's easy to design something, but the most difficult bit is to get somebody to use it or to work on it. So that's where our team in IT, we work as an interface, and we make sure that we bridge the gap between the operations and the user team. That's what we do. Right. So having said that, I work around a lot of fleets across the Middle East and North Africa, which is the MENA region, and in the Asia Pacific. So the last week when I was contacted by Perumal sir, I was in the middle of the scene near Kenya. But I promised Perumal sir that I would love to be a part of this, and I would be taking it forward. So just to get things started, and I am mindful that we are going on definitely on a shorter time for this session. We'll just split into, what would you mean by virtual reality and augmented reality? Yes, it's easy to go with the definition that you would see on your screens, but to put that into perspective, I'm sure you all are already using these technologies, but for maybe in very different formats. When we talk about augmented reality, this is nothing but and you use your smartphone devices. Nowadays, I think that's what is become a basic necessity. I mean, back in the days when we were studying, I think mobiles were just being introduced, and we said at least water and electricity were the basic necessity for it. And now you need internet as well. So these are the three things without which you can not survive actually in today's world. So with a smartphone device that's connected, to the internet, or you have even AR applications which sort of augment the experience. So um, coming from a perspective of oil and gas, what happens is using augmented reality is when you can actually try and visualize something. I mean, it's not there. You're just trying to put something into that, sort of a platform that you can sort of work around with, right? So, as a very simple definition is, it's like augmented reality is merely adding to the user's real life experience, right? So that you can just achieve by using a normal smartphone or or even a tablet device. I'll probably show you a little later into this presentation a short video which sort of gives you how all these are put together. And then you have virtual reality. And again, you'll agree with me when I say that many of the technologies or engineering divisions across companies, they use VR. I mean, you normally have somebody wearing a headset, they look into it, and then you would see them doing all weird actions. But it's actually them placing themselves inside the real world. And about 2 or 3 decades ago, this was all in theory. It was all a concept, rather, if I should say. Now it's something that's achieved, and you can actually see people living to, they can't do without it. It's these forms of platforms that actually help to reduce a lot of risks in the work that is involved, and it also gains or helps in gaining knowledge. I mean, it's some one way to sort of expand your knowledge in a certain subject. So with VR, it's just like these are simulation. I would say everything is a simulation, but it's just the different ways you can put it. In VR, what happens is you basically put yourselves in, you put a VR headset, and then you are seeing something which is not exactly real, but it sort of mimics the entire real experience. And that is something where you can sort of try and do things where you can simulate real world problems, or you can even simulate an emergency and how you act upon the emergency and then improve on it. So these are tools that you would use in a VR technology. Right? So you have augmented reality, and then you have virtual reality. Now, these might sound same in terms of how you see them. There's definitely a simpler way that I can put it. So if you'd see the screen on your what do you call, on your view now, you'd see that the first picture shows augmented reality. A few years ago, this was a very famous game, and I think it is now even. My son used to play it quite a lot, which is, you had this game called Pokemon. It was a character where you launch the app, and you're just walking across your street, or you're just there somewhere in the mall, or you're at any real world environment, and then you had to spot where this Pokemon was. It was not physically there, but it just would appear on the camera, then you tap it, or you run after it, right? So this was, it was augmenting that real image behind, and then you had something that was within your smartphone, right? So this is something which everyone uses it, and it's quite freely available. Whereas virtual reality is something which you can see the photo there. It's one of those process engineers wearing a headset, and he's actually trying to simulate, how a piping assembly would work. I thought I'll use that picture because this is what I get to see almost every day at my work. People would walk around with headsets before we commission a vessel. So, before we start production of an actual, I would say, product on a refinery, we normally train the process engineers by wearing this VR headsets. I mean, they get to walk around the facility, and trust me, it's not that they will even go and hit any of those piping assembly. It's designed to match that you are actually within the system. Of course, you have the look and feel, but this would actually tell them as to where those switch gears are. Where would you normally turn on, check for your pressure gauges? How would you navigate your way out of a such an assembly if there was an emergency. So this is where we try and use it, in the oil and gas environment. So speaking of oil and gas, and this is something which I know may not sound promising now because the price of oil is really, shot up the ceiling. It's definitely difficult for most of us when the price of basic fuel has gone up. Whereas in our industry, we call it good for us because that's when most of the production happens. As of now, yes, we have the war. We just came out of a pandemic. During the middle of the pandemic, the demand for oil was really low. So obviously the oil prices were pretty much stagnant around the time. And then just over the last 2 to 3 months, it's something which none of us have experienced before. Just the graph has shot up to a level which we are also trying to keep up with. But if you see on the picture, I mean, what do you get out of oil? Almost every household item that you can think of has got an element of oil in it. So that's why I thought I'll put in a holistic figure which says, what do you get out of oil? Most of us think oil is just used for getting the basic fuel needs. I mean, we use only petroleum and diesel or maybe even kerosene, and that's it. And then we forget about oil. No, there's a lot of byproducts that come out of it. And, you have a lot of all these, you're talking about non-stick frying pans, you're talking about electrical cables. There's an element of oil which is there in every bit of this. But to produce this, we rely on complex machineries. And if a person needs to understand how these machineries work, the solution which we use in the industry now is AR and VR technology. We try to actually simulate how we can bring these products out and then how we can sort of meet the demand of the market. So that's very much my first point on the slide, which says it's technology heavy when we say, and the challenge is pretty much double. So with oil and gas companies now, the biggest challenge we face is in terms of our costs in production, particularly when we hit a new exploration site and we know there is oil there. We know there is a lot of probably even natural gas. And the next challenge is to see how this can be used, how this can be broken down. Our reliability on fossil fuels is such that we try to squeeze and get the maximum out of what is available. But to do that, and with the kind of machineries that we have, you need to be trained actually to see how it works, and this is where we do this sort of training methodology. So if you look at my second point, it talks about the same expenses, but on-site training is extremely dangerous. Now I cannot simulate a high pressure valve that's just about to burst out because of a incompatible I would say a valve opening or maybe a hatch inside. It would have failed. But if I were to go and stand in front of real machinery, and if that happened, that would result in a fatality. So the best way for me to troubleshoot that and to see how to respond to that situation is to simulate it, right? Using a VR experience. So I would so we normally train our set of people. We take them through an induction training, which is they are actually taught about what the machinery is. See, regardless of the background that they come from, they could be from any industry experience. When it comes to oil and gas, imagine yourself just wiping off the slate and then starting right from scratch. So an induction is given to know on the basic PPE gear that you need to wear. PPE stands for personal protective equipment. Following that, then it's about the operational aspect, and that's where we use such technologies or machinery. So they get a VR experience of how they should address that valve issue. Just an example that I gave, and it also has a lot of benefits, on using these technologies. And one of the biggest ones is your training costs come down. Training is one of the, I would say, biggest. We put it as operational expenditure. We have capex and opex. There is a capital expenditure which you spend to build the infrastructure, and then you have the operational expenditure which you use to keep that infrastructure running. In that, training takes almost a significant amount of cost in that. It's like getting the people to understand the know-how of how to work on that platform. But rather than do it physically, when you use AR and VR technologies, it actually sort of brings down that cost by I would say straight off when we began this in our organization, we were able to achieve a reduction of almost 30% in our training costs because not only in cost, even time. We were able to expedite to bring or mobilize people onto the project because they were being trained on the VR technology. They were a lot more, I would say, exposed to that knowledge. rather than me having to sit and show them how to use the machinery. If they had a hands-on experience using virtual technology, their skills were much improved actually. That's what explains in the second point as well. So hazards were minimized, and you were able to get a better throughput actually when you use such technologies. And the best way of doing this is we could simulate multiple scenarios, right? So you can, it could be one of the best scenarios I think I enjoyed as part of the VR experience is when you travel offshore, you're bound to either travel by air or by sea. The last couple of months I've been doing a lot of sea travel. And the biggest problem when you travel, I wouldn't say problem, a challenge when you have at sea is weather, right? You can either do rough tides or smooth tides. Now, if it's a rough tide, you know that the weather is really very hostile, and but yet the production must go on if we have to keep up with the daily targets. Of course, we wouldn't do production if it's a massive storm, not that way. But when we talk about tides, vessels can still be moored to one place, and you could probably feel a bit of oscillation, but production still happens nevertheless. Because every time you pump out crude from, we call it as the oil well, it has to, you can't just store crude as it is. Otherwise, in less than 48 hours, it just turns into sludge. And so when we pull out crude, we mix steam, keep it, it's like saying keeping it diluted as long as we can, and then we sort of distill it and get all our byproducts out of it. But to do all this, there's a lot of machinery involved. There's a piping assembly that you will see bringing all the oil in. Then it will go into the fractionation column to break it into different byproducts. Then it is stored back into the tanks. Now all this can be simulated sitting in the control room with this VR technology actually. So we do something known as sea trials. Right? So in sea trials, what we do is we don't use oil, and the best thing is salt water. We have plenty of salt water in the sea. So we actually take salt water from the sea in high pressure and pump it into these assemblies. So it helps us to determine two things. One is to see if the entire structure is working fine, end to end. And the second bit is to see if there are any lapses in between. I mean, if there's a leak or if the loss of pressure, salt water is the best medium to do this. So we pump salt water into these machines, and it's pumped out as well. And when we decide to switch it to mainstream production, that's when the actual oil is used in. So this is like in our terms, when we studied in software engineering, we had something known as UAT, user acceptance testing. So that is known as sea trials when you work in the offshore industry. That is greatly achieved by using VR technologies. So training is definitely an aspect which helps. And obviously, one of the requirements of such simulation technologies is to handle emergencies. For us, every day is an emergency, regardless. We're trained to be prepared just in case if something went wrong. The risks involved are pretty much the same, similar to what astronauts would probably have to think of when they're up there in the space orbit. Now in the sea, it's just that yes, you're down on Earth, but the risks are different. So we heavily rely on these technologies. And at a personal level, what happens is when you use such technologies, it actually helps reduce the risk of injuries, right? And you can actually see that it can even decrease hardware damage. There are people who may try to operate an equipment without actually having knowledge of how to do it. I mean, it's easy for me to put it into theory or tell you this is how you switch on the unit and this is how you switch it off. But there could be a sequence of standard operating procedure that you need to follow. This can be simulated to a great extent using VR technologies. And another good example, which is used even to this day, is in the aviation industry. Pilots, they if they're not flying, they are in a simulator. Their job is to make sure that they are able to do maybe 3 or even 10 hours of flying with different scenarios of emergencies that would come in. And that's how they train themselves. So these are technologies which particularly the oil and gas industry has now relied on. So speaking of which, I've just managed to get a video with one of the partners we work with. We work with Geospatial Technologies. They're based in India as well, and they have an office in France. They were kind enough to allow me to use this video for this webinar talk series. Very brief on what is AR, VR, and then we're heading to something new, which is called as mixed reality. You will see it in this short video, and then I have a few pictures at the end of it. Let me just try to play it up on screen. Right, so that was just a very short video for you all to understand what's virtual reality, what's augmented reality, and somewhere between these two, we have something known as a mixed reality. And this is when you combine, both of these technologies and try to get a feeling of, a real life experience. This is like one of the classic examples I could give you of a mixed reality from our time. I would say that was between the 2000 or the time when we were in college was this movie Matrix. I'm sure you've heard of it. It came with 3 sequels as well. Now, this movie, when I first saw it, I had to probably see it 10 times or even a dozen times to understand what the storyline was. But it relied completely on mixed reality at that point in time, where they were talking about missionaries taking over the human race and things like that. That of course was a bit exaggerated, but when you look at it in the real world scenario, that's the third dimension of simulation, that is mixed reality. So I've just put that in the form of pictures. What you see on your left side of your screens are technologies that they use as part of augmented reality, where you use smartphone devices. So you try to use the image of what is there, and then you try to superimpose it with something. As you can see, it can be used for home decor and planning. As you can see, there's another person who's trying to probably interface one of his wristwatches, trying to see that he's not actually wearing one, but he's trying to see what would look like, a possible model would look like. And then it's, of course, used in biomedics as well. You can see that in the third one, it's a photograph of greenhouse where they're using augmented reality to see the different species of the plants that have been put in there. You switch to the right side of your screens. Again, it's very simple. You have headsets, VR headsets that you use to try and simulate in the real world. Nowadays, you've even started hearing about metaverse. This is probably a little more advanced of what we're talking about. That is something known as yes, you can say it is a combination of AR, VR. And I'll show you a slide where I'm going to leave this presentation with, and that is just to tell you what's the next way forward. We call that as the 4th dimension of simulation reality. So if I had to put this into a graph, this is what we call as reality versus virtuality continuum. So in the middle of, so MR sort of sits, that is mixed reality, sits in between. AR and VR. We haven't yet started using MR in our line of work yet, but there are certain other industries, particularly the construction industry, which is using MR at the moment. This is and a good example of MR being used very recently on some of the projects was when we had the Expo 2020 in Dubai. They actually used a mixed reality to see how the different pavilions were going to be placed. It was over an expanse of almost 5-6 hectares, and we're talking about people literally having to walk and experience every country's pavilion. And before even the structure of the pavilion was designed, they used MR to sort of simulate and walk through it. I mean, it was within the confines of a room, but the person would actually have all the VR headset, and there was a look and feel as well, right? So in earlier slides, you saw people were using some sort of maybe a remote handset, or they had a gloves. Imagine you had sensory perceptions on those gloves. So you actually felt like you were touching something. Now that's called mixed reality. That's taking it one step further, right? So before I could just get into the Q&A session, this is what I would say is a food for thought, because we are moving on to the next dimension, which is known as XR. These are the possibilities are endless. This is what we call as extended reality. Look, so reality never ends. There's only one thing that's real, that is you and me talking to each other right now as we over this platform. Everything that else you see is mostly simulated, which is sort of an aided tool that you use to improve your quality of life or to improve your knowledge. And when you put all of these together, that's the new mode. And again, it's not something that we are using at the moment, extended reality. This is a subject of its own, and I'm sure probably in the next few years to come, it's certainly going to sort of dominate the industry, right? So with that, yes, that's what I want to leave you all with. And if you have any question and answers, please feel free. I'd love to take them.
Mr. Sujith, hello?
Yes, please.
Yeah. It was a great presentation. And one question which I have is like, how close is the your practical? You showed me your oil and gas industry, which has been into virtual reality. How close is it to the real life? Like, is the simulation as good as the reality, or there's a difference between what we experience in real life and what is simulated?
A good question, Vasanth sir. Certainly, yes, there is always a difference between the virtual world and the real world. And if you'd ask me the accuracy or to what level it is close when we do such simulations, I mean, that's what even manufacturers of such equipment tell us. Nothing is real, but you can at least take it up to a 95% accuracy. Why they leave that 5% buffer is because there could be design changes. I mean, when we sort of made up the structure of the refinery or piping assembly on a unit, at that point in time, the VR team would have started designing the 3D modeling as well, because that is what they're going to feed back into the VR headset, and that is what the user would actually experience. Now, by the time it hits the production or actual time when the vessel goes onto the sea, there could have been probably a substantial change, maybe in one of the lining of the piping, which we may not have captured in the VR system when the person was being trained. So that's when it could come up as an NCR as well. When we do such audits, it comes up as an NCR, as a non-conformity, and we have to take a corrective action there. So it certainly helps to just as I repeated earlier, which is for the purpose of knowledge transfer. But when it comes to the real life, there are situations where we do have to go, cater to that 5% area and then sort of correct it. But the closeness of using such technologies is very much similar, and that's the whole idea of getting people to or training people on such technologies.
So in your company, normally you take people. This is how you train them in full.
That's correct.
All the people on the shop floor will be trained on the VR first, and then put on the shop floor.
And then put onto the production floor. Yes, that's correct. So we even before we take them on a walkthrough of the actual vessel, we first when the induction program is done, they are switched straight into the VR world. I mean, that's how, because they have a lot more questions when they start with the VR. They would even ask, can you tell us what is a gantry? Now, a gantry is something which you would use to move from one module to another. I mean, you would have seen it in videos where it's like a steel structure where you just walk across, like one of those suspension bridges. But when you walk across a gantry, when you do it using VR technology, it would even simulate that. So you stand on a platform, and then we would simulate even a sway if the vessel was actually sailing, and if there's a minor movement, and that's how the person actually sort of adjusts or accustoms himself to walk across a gantry platform. And let's say if he was being trained on how to use a panel we have something known as an ER module, which is the main module in a vessel that generates the electricity required. So what happens is you can't rely on, we don't carry huge batteries on vessels. We use fuel. I mean, a part of the oil that is being pumped for production, the same oil is fed back into this. It's a diesel generator, and then it just supplies the power for the entire unit. Now, imagine having a vessel to do at least 100 megawatts of electricity, and that's powering all the nearby rigs which are connected to it by a subsea line. To simulate, now if an electrical engineer is on board, he needs to know how the entire panel system works. So we take him through the VR first. He gets to see every panel one by one, and it gives him the entire wiring diagram. And once he is familiarized with that, then he knows where every unit of the vessel is geographically placed. He doesn't even have to come back and ask us, can you tell me the direction to the turret module? He would actually walk straight to the turret because he's already seen it on the VR. So yes, that's how we do it in our line of work. We train them first on the VR, and then they move to production.
That's great. That's great.
Sujith,
Yes.
so my question is, there are students, they have opted for AR, VR as a specialization.
Mm-hmm.
Okay, what is your input for that particular students? What are the things they have to learn and how they can excel in that particular field? What are the things they have to do that we can give your suggestions, because some of the students are joined in the meeting. Maybe they opted for specialization of AR, VR.
Yes, sir. Okay, good question as well. Now, if this question was asked to me at least even 2 years back, I would have been clueless because I would have only told what the definition of AR and VR is. I wouldn't have been able to tell on which direction to rely on. From at least the 2 years of experience that I've had of the entire work experience on AR and VR, for students who are looking out to see, I would say, opportunities in AR, my advice would be don't try and club both of it. You always try to learn on one technology first and then move on. And the best way which they can even start even before they have a hands-on is with AR, augmented reality. And this is very simple because you have a lot of learning kits now available, particularly when you use your standard mobile phones. There are AR boards, or we call them as coasters that we use to keep your teacup or your coffee cup on. Now that comes with a sort of a barcoded design, and the moment you just move your phone device onto it, it has a 3D modeling image. There are two kits to it. One is 3D models that you can use to study, and then there are application development kits. You get this. I mean, if you just Google on AR development kits, you have applications or even I would say 2D diagrams that you can download off the internet, and then you just scan them over the phone, and it just opens up a sort of a coded page that tells you how it has simulated that into a 3D image. What were the I would say the intrinsics used? This is by using a simple AR kit. I do apologize I didn't bring that into today's slide, but certainly I will share that with Hermas a little later today on what would be some of the reference tools that they can use for AR. And if you feel that no, that's something which I'm already relating to, when you look at virtual reality, this is something which still requires a practical experience. There are when we talk about companies like Facebook, we talk about Microsoft. Microsoft has been one of the leaders who have tried to evolve. 2 decades ago, Microsoft was more specialized in developing any sort of applications. From where we studied, we were talking about Windows NT, and those were our technologies. And then came the cloud technology, which is still there. And now they're also going into the virtual reality technology, and that's where they're trying to help people understand what's the virtual environment before they get a first-hand feel. So particularly for students who are in the mixed background of such similar technologies, I would always advise them to always be on the lookout for releases. Microsoft, even for that matter, if you've heard of, our days it was called as AutoCAD, which we use for 3D 3D modeling back then was, I wouldn't say it was modeling, it was 3D visualization, what we had in AutoCAD. Now you have something known as the Aviva PDMS. It's called as AVEVA, Aviva PDMS. This is another VR technology where you can physically sit and design, as though you were walking into a 3D cabin, and then you sort of execute it where you use the controls and walk into it. And then you design along the way. I mean, you use the technology and you said, okay, I need a shelf here. There's supposed to be a shelf unit here. You can actually place a shelf unit there and then carry on walking into that, the screen. And then you decide saying that there should actually be a two-way swing door. You can bring in a two-way swing door and put it. And then when you turn back and look, you can actually see that you've designed it as you walk along. That's how it has evolved. So for learners, the learning is definitely limitless, but like I said, it doesn't stop with these two forms of reality. It is moving on to a mixed reality and extended reality, which is what I left with. And particularly for learners who are from this particular department, it's definitely going to be a nice learning curve, actually.
Thank you, Sujith.
Sorry, just to add to what Sujith has told. Sorry, I'm Nagarajan here.
Yes.
So for regarding learning tools, Sujith, what do you think is actually the cost of learning for all this? Because, for example, virtual reality headset, it's like, there's no virtual reality headset that has been officially launched in India, which is, for example, Oculus is the one thing which is a cheaper one, but it has not been officially launched in India. And the other virtual reality headset like Vive or something else, Steam's Vive and those kind of things.
Correct.
So those are all costing like a lakh or something like that, right?
Yes.
So as a student, so how can we motivate students to learn this? Or even for development, if you say for development also, the laptops require very high-end graphic cards and all those kind of things. So you can't even find a laptop which is capable of VR development, which is less than a lakh.
Very true. Very true.
So
That's right.
Personally, I have felt this is the biggest hurdle which we are facing in India. So do you think that we can do anything else, to bring down this cost or anything for learning, cost of learning?
The cost element, yes, is when we talk about investing in resources, particularly for AR and VR technologies, yes, it's something which we can't even imagine. It could run into 6 or even 7 figures, particularly in the Indian market, and so is the case here as well in UAE or even any of the Middle East region. Companies do think twice, but when we talk about it from an educational perspective, yes, not every student can probably afford even a VR headset. We are talking about VR headsets, which a basic model can even start from 50,000 Indian rupees, and then it goes up. The best way for them to sort of motivate them or to get them into that, to explore such technologies, yes, we would always say we'll have to invest on one or at least two of these units. And then you have multiple scenarios that they can work on. Now, if we see again, VR or AR is used in not just one specific industry. I took the example of oil and gas because I was able to maybe give a few examples on that. This is used very widely nowadays in aviation as well. It's used in construction, even in healthcare. If you've noticed, they've used VR they mix it into robotics, and you've got surgeons performing surgeries sitting miles away. I mean, and they're looking actually into a camera, and they're trained using VR technologies. I mean, basically, even if they had to join two arteries which were cut in between, but for them to get that, for students to get that, I would say curiosity, the best way is they would. Internet, of course, is a good source. I could easily say you just go and Google it up. No, you will. The best way to do it is try to think of scenarios. You pick an industry. Let's say the automotive industry. They're also a good industry that uses AR and VR. Let's say with all these new technologies that goes, I normally say that nowadays the cars that you see are no more cars that we used to have before. Earlier, a car was just 4 wheels, a steering wheel, a seatbelt, and a set of gear systems. You've got a lot of technology packed into a car now. You've got cruise control. You've got anti-braking system. You've got automated park assist. There are so many features that go in. All this works using cameras, using a lot of apps that's built in, but this is all simulated in the industry before it's sent into the production line. And for students, the best way to get the curiosity is pick a domain. Can be automotive, aviation, but try to be specific on that. If you try to bring in everything at the same time, there could be a possibility that they might lose steam, or they might not. They'll say that this is too vast a subject. How do I apply it into one particular domain? I would say rather specialize in one particular domain and see what are the possible scenarios there. When they have adequate number, let's say for at least 5 different scenarios they've picked up, then it would be a good approach to, I don't know, there could be companies who are maybe nowadays on the verge of going into or implementing a VR system. And if you have an idea in mind saying that I'd like to simulate these scenarios, that would be the first choice. Every company now has an, I would say, particularly in oil and gas, one of the biggest companies we work with in the region is Saudi Aramco. Aramco has a different division which is within their IT team called the VR team, virtual reality team. And they've been on a hiring spree just after the pandemic because they wanted specialists to not exactly fly in and see what their production plant was. They must be sitting remotely away. Sometimes it would be a plant specialist. He would log into their VR server. They are, of course, shipped the VR headset and devices in advance. And they sit from there and then they give their expertise on how to use that entire platform. So I would say start with one particular domain, see what are the scenarios you have behind it, and then try to see if you can implement it either with a corporate company, or there are definitely a lot of design companies who are, leasing out these equipments, and it would certainly help there.
Okay, Sujit, thank you.
Thank you. Thank you, Mr. Nagarajan.
Yeah, Sujit, good evening. A beautiful session. Though it was Greek and Latin for me because I belong to the mechanical engineering part, but still, whatever I understood, VR is something like a video game. Like we sit in a bike, and if you just do, it looks like we are running into the tracks. And AR is something like if I have space, I can fill with things and stuff like that, isn't it? So that is AR. So my understanding is that usually in oil and gas, as the topic is very catchy, it was not available. People were not much into AR and VR in oil and gas, but other industries were into. So after the introduction of AR and VR in oil and gas, I believe that you people use it for some fixing some equipments or something of that sort, or AR and VR in oil and gas. And after introducing this AR and VR, what is the budget ledger you have got, or any workers you have reduced or something of that sort?
Yes. So when I wouldn't say that we have reduced. By the way, VR and AR is not a substitute to a HR workforce. Unlike other fields where they say that automation has sort of reduced manpower, what a human should do, automation has taken over. This is definitely not an automation technology. This is just a simulation technology, which is used as a tool to enhance your real work. So what we have actually reduced in terms of um, human, I would say, engagement is the risk of injuries. We used to have a lot of work-related injuries before implementing VR technology because it was a lack of knowledge of how to use the actual system. We've had a little, I would say, maybe a 5% reduction in, I would say, production defects. Just because of the wrong knowledge that the field operator was using, the end product could be something totally different, and that was something which was rejected by the industry. But with the VR, we were able to correct that bit as well. So we more or less would I would weigh the positive options more. The only con side or the negative side that I would say of these technologies is just the cost element, which was rightly raised by Mr. Nagarajan, and it's a heavy investment that you need to do. But when you look at the positive side or the pro side of it, it's always been an aid that has helped industries across the spectrum actually. And definitely it is not something that would replace HR. It's not an automation. It doesn't do anything automatically until we feed in the data or we sort of built in on that environment inside that VR platform. So yeah, it's definitely a lifesaver. That's what we call in our line of work.
Yeah, great, great. Thank you. And one question is out of syllabus from my side. Like, what about AR and VR for blind people, like any vision challenge people? Do we have AR, VR supports for them?
Yes, and a very good question, Mr. Thomas, that you asked. Let's not take oil and gas here. I was doing a bit of reading. In fact, as we speak, when we were into this, I've just enrolled myself to take what we were discussing about extended reality. Now, especially for hearing impaired people or visually impaired people, how could they use? Obviously, they can't use AR and VR. Now, that is where the concept of extended reality comes in, and that's where you have these handheld gloves or devices with sensors that if they were actually trying to, let's say, touch a phone device. Now when they touch something, they would know they're working around with it. They can't visually, they don't need to even wear a headset, but just by using those sensory probes that are attached to them, when they actually pick up a phone device and when they sort of twist it, they would actually feel the edges. They would feel if it's a smartphone, obviously you don't have any keys on them. Or let's say they were trying to pick up a cup which is nearby. Now, they won't feel anything in their hands, but they can at least sort of improve their motor skills. We call it as the your dexterity of your hands, or they can position themselves. Lest if you wanted to drink a cup of water, how would you bring it from the table to your mouth? That's something which is been extended reality, where it's the next level. And you must have seen people wearing advanced headsets with sensory perceptions. Even there are people. Another movie which used extended reality was Avatar. If you've seen that movie, which had extensive, the actors behind the screens, they were actually outfitted with all. It was like a bodysuit, and they had all their probes connected to it, and that's how they were doing the movements. And even if they fell down, I mean, they were not actually falling, but they had the effect of a fall, and it simulated even an injury. So to that extent, yes, that's where extended reality is heading, and that's how it will cater to this. But it's again a very vast subject. The technology is being developed even to an extent that we can't imagine when we talk about incorporating people from other walks of life as well.
Great, very touching. Thank you.
Thank you, Thomas. A pleasure. Yes.
So, audience, do you have any other questions?
Not question per se. So just for information, I have been trying to study VR and AR actually. So that's why I came across that cost of learning and those kind of things. So probably I will just pass on the tools that I was starting to study for VR development, so that you can pass it on to the students, and probably they can use that for studying. So
excellent, sir. Yes, I would be more than happy to assist in any way that I can as part of this. I'll definitely I'm there as part of this alumni, and please feel free to reach out to me with any queries, and I'll be more than happy to chip in the best way that I can.
Yeah, great. So if you have no other questions, Permal sir and Sujith Menon, Vasanth, shall we go for the closing remarks?
Yes, Thomas, sir.
Yeah. So thank you. That was Sujith Menon of 2004 MSc Software Engineering. Thank you, Sujith, for the wonderful session on VR and AR simulation technologies in oil and gas. So it was indeed the 99th webinar talk, and you're mesmerized with the beautiful presentation. Thank you so much. Thank you, Perumal sir and the Department of Computer Science and Engineering for roping in Sujith Menon after a long gap. 2015 he was in the campus, and this time he's in the webinar talk. Thank you so much. Thank you, Sujith. It was a very short notice what we gave through Perumal sir, and thank you for accepting that and being here to mesmerize us. Thank you so much. SRECAA Alumni Association feels happy to host you for this evening. Thank you, audience friends. Thank you, alumni friends from all over the globe. Thank you, student friends. Thank you, faculty members, for being here. Thank you, one and all.
Thank you. It's been a pleasure. Thank you so much, and I genuinely liked delivering this today.
Thank you, Sujith. Thank you.
Thank you.